connecting a fiber network is a graph problem of you have to actually build a network that's connected various ways. There are breaks in the network. It's not as simple as circling an area and saying focus. So there's a lot of detailed analysis, that's spatial analysis, graph analysis, on top of just looking at spreadsheets and balancing your budget EBITDA. So basically, we work on all sides. Plan, we say plan, operate, and build. We're going to help kind of analyze the financials before going into a network, maybe trying to find the best places to deploy or the best speed to deploy. We keep track on construction, where your capital spend is going, give more insights into how it's going, maybe things are going well, maybe things are not going well, and then all the way through sales and operations, where you actually have to get customers on board, make sure they're happy, making sure your technicians are getting where they need to go on time, and that ultimately your net promoter scores were achieved. And there's a couple of metrics on the board just to give an idea of how big this problem is outside of just the large providers that serve a lot of the country. So the FCC does all the reporting analysis on what's considered served, underserved, and unserved in the US. And at this point, a lot of money has gone into the past few years. It's much better than it was 3 or 5 years ago, but there's still 7.2 million homes right now that are classified as unserved or underserved. The FCC definition of that is 100 meg per second, which is still not like super fast. And then 26% of homes in the US actually only have access to one provider. So if you say they are served, they can get 100 meg, they may not actually have the choice to pick a provider. So they could be in a monopoly where the prices could go up or prices could go down. So for data analysis, again, these competitors may go in and see a gap in the market. Well, there's only one provider, it's a cable company that's not going to extend their network. I bet if we raise $50 million, we could go compete with that and make our money back. So helping on the financial modeling, tracking metrics throughout the build, and then ultimately managing the books long term. And then the CapEx that's being committed. So again, the federal BEAD program right now is $42 billion. If you add on private dollars on top of that, basically private investment will go and try and jump on the money match or increase. So study by the RBA basically said within the next 5 years, $167 billion is going to be spent in this space. So that's kind of our business. That's the niche we're trying to provide in the market by finding the people that maybe don't have a data science department. They are looking into a niche part of the build. We collect data, monthly metrics, key KPIs. We clean the data, we snapshot it, we do a lot of time series analysis, and then a lot of front-end dashboards reporting are what most people see when they think of the analytics. Let's say a couple examples of our classic what we do. This is, again, stuff that takes days, weeks, or months to build, which is the opposite of what we're going to talk about with BIOD analytics. So as an example of the type of data that we play with that's kind of interesting at scale is utility poles. There are millions of utility poles in the US. This is an example of a few thousand that we collected where we're doing a cost analysis. So when you install fiber optic on a pole, it can cost maybe $500 to $1,000 to apply for permission to get on that pole. And then if work needs to happen on that pole, like there's not enough space to meet clearance issues, you have to make the pole taller, move stuff around, it can easily cost $5,000 or $10,000 to reconfigure a pole. So when people talk about bridging the divide or building these networks, a lot of the problem is with permitting and things like getting the pole owners to actually make space. So again, you can see a small build at $10,000 a pole can turn into hundreds of thousands, millions of dollars very quickly. So basically being able to take a lot of data about the pole. We do some LiDAR analysis, some photogrammetry analysis to look at different heights, thresholds, clearances, and then add cost modeling for what different configurations would take. And so we end up with this map as an example where we have basically categorized simple regular green pole. This is really easy to attach to, this is low cost. Yellow is going to be a certain threshold, and the red gets very expensive. So we can kind of run a graph analysis on this to find either the most optimal routes to build or decide that something doesn't financially make sense and the provider would have to do a different approach. And then the other one that we do more of is working with investors or private equity groups or operators that have to report numbers back to their investors is calculating metrics on a monthly basis. So it's probably used to like MRC, like monthly recurring charges, annual revenue per user, EBITDA, things like that. But we also need a lot of operational metrics on these builds. So how many homes were planned to be passed, how many did we build, what was the cost per foot, how many sales were made, how many scheduled installs. So basically we write detailed pipelines to capture the data from a bunch of different software systems. We snapshot the data, we keep it in a time series format, and we're able to basically let an investor pull up a view that looks a lot like an income statement where they can look at, yeah, their costs, their ARPU, their churn, alongside other metrics like sales, cost per foot, how many homes we built this quarter. So again, this is stuff that's very structured, very well defined, and kind of doesn't change. If an investor gets a spreadsheet at the end of the month, 3 years, he wants it to look the exact same. So the fun part now is the EDA, the exploratory data analysis. So one of the big problems with coming up with these production-ready dashboards and things that are very known is how to get there to start with. And pretty much everyone I've ever met, they love charts, they love dashboards, they love graphs, they'll start to tell me how much they love graphs. And if we talk to anyone, what kind of data do you want to see, or what should it look like, the conversation stops or just goes completely sideways. Someone may remember what a dashboard they saw 5 years ago looked like. They may try and draw it on a napkin, get some really hairy descriptions of, hey, I would like to know text per month in this region and this. I think we got a list of 300, just a list of things this person would like to see. And our job is to turn that into, well, we have to figure out what system it comes from, we have to write the code to scrape the data from the system, we have to snapshot it, we have to QC it, and then we have to kind of build the views they like. So we can spend weeks on something. Oh, we built the Sankey diagram that shows your flow of your customers, the different stages they fall off, and when they churn. And so we'll be like, nah, can I get a bar chart? So we spend a lot of time trying to understand what the customer wants. So with Plotly's AI Studio product that they came out, they gave us early access where we got to start using this with real customers, with real data early on. We used some of the legacy products. They were very helpful and useful for this. And the chatbot worked really well when you kind of know what you want to get to. You can ask a question, you can maybe have a back and forth. But this kind of analysis just took it to a whole other level. Basically, we can just get as data as simple as a CSV. So talk to a client, hey, this example here's the same whole data set, but let's say, hey, send us the CSV of all your customer packages. And we drop it in, and really quickly, it will start to, we'll say, decide what may look interesting. You can give a lot of context, or you can give very little context. And LLMs are really good at interpreting, here's what these columns mean. This looks like this data is about customers and packages and plans. And maybe you want to see a time series graph of what packages are on decline, or maybe you want to see a scatter plot of different regions where customers are churning. So what's really interesting at the collaborative analysis phase is you don't know exactly what you want to see, and instead of spending weeks talking about a problem or days trying to code a piece to show it to someone, and the gap between the executive that wants a problem solved and the user, the programmer that's actually writing the code, you narrow that gap where they could be in the same room talking in real time. And the vibe part is going to be us working with customers, and obviously talking with that LLM is, hey, actually, this looks really interesting as a scatter plot. Can we make it a bar chart? One of the more interesting things we saw with the diagram on the screen is we took that same poll data set where we have maybe 5,000 polls, where we've done a lot of clearance and structural analysis. And it generated a map, which is great. It generated a map. I didn't have to code a map. It was there. That had all the classifications. You can zoom, you can click on stuff, you can slice, dice the data. It started to generate charts I never thought of. It had a histogram of basically the different clearances and the average separation on different poles. Then when you start to see the data, then it becomes really, really interesting. And the big thing, we'll talk about what Vibe Analytics is on the next slide, is it's not making decisions, it's still kind of prompting like, oh, here's this thing. You can really quickly say, no, actually, I don't want that. That's nonsense. But could you make something like this? It's really, really good. And just the time, this is taking minutes to go back and forth and generate a new graph chart without having to spend like weeks talking to someone, trying to figure out what they want, coding it up, locking it up, and then ultimately showing something they may like, but they may not. The second big use case that we're going to be using in the future with we call Vibe Analytics is just the Mockup phase. So after going through that exploratory phase where we kind of know this is what's interesting, this is the type of data, like maybe someone had an idea, I really want to know about installations, where we can show them, oh, well, here's the 5 different ways that we can show on-time performance, mean time repair, maybe the volume of tickets per day, or the average time to close. We can kind of mock that up, and they can say, okay, actually, this was really good. I want this to arrive at 8 a.m. every day. The code is available. We can basically copy that code, put it into production, go through our regular debug, test, commit, and deployment process. So we can go from kind of exploration to a mock-up and then put it into production. And then I think working with Plotly, their long-term vision is really the self-serve of the data. So we do a lot of work to collect and refine the data and QC it for our customers. But still an executive may want to question or play with the data, and they're not going to have the skill set to get into Python or Jupyter Notebook and start coding things. So basically giving the ability where we are able to export from our data lake the type of data that can be brought into AI Studio, where then they can vibe with the data where they don't need to hand off the work to a developer. Again, it's not something that's going to go into production, but it may spawn some ideas of, man, actually, having that stinky diagram that Patrick said would be great if I had it. So for Vibe Analytics, basically the definition, AI-driven code-based approach that allows users to interact with data through the natural language conversations similar to brainstorming. So I think the big critique I've heard of Vibe coding and Vibe Analytics is you can't trust the code. The things hallucinate, they don't know what they're doing. The big difference with this exploratory data analytics or Vibe Analytics is it's really just building code to spec. It's not calculating a customer's churn. It's not trying to decide what average installs per day looks like. It's just using an LLM to generate the code to really visually display that. So it's really good at building the pie chart, building a line graph, doing basic pandas and pollers work. So it's not really doing anything other than speeding up the development process. So the big drivers behind that, and a paper by Nicole Schrag from MIT is linked here, but the big drivers are, while BI tools are great, there's still this walled garden. So Tableau and Power BI, they're great tools, but you're very much in their ecosystem. You're gonna have to use their tool set, and you're gonna have to have users that are trained on their tool set. Whereas someone that just wants to go in and maybe just play with data, just kind of need something a little bit simpler, bigger. And then we all know this is the reason I'm in business. Hand coding is the gold standard. Someone that can get in there and have a team of people that can actually do that really detailed analysis, take one step and then take it 3 steps further, and understands actually statistics. But not everyone has the time for that, and there's a budget for that, and a lot of our customers are either smaller providers or they just don't have the investment for data science teams or developer teams that aren't solving other problems. Dedicating people to just that is very tough. And then chatbots, while they're great, they're kind of limited to the imagination of the prompt. Or I may ask what my churn was like over the past 3 months, and maybe tell me a number, and it made me think of another question, but it's not going to generally see something that pops out like, oh yeah, here's this histogram of all your data. I assume I'm about good on time. Quick overview of our platform and kind of where AI Studio and just Plotly Dash fits in. We use oil and gas kind of analogy, so typical ETL diagram. On the left, we have what we call our data collector, where we handle data ingestion, so we write APIs or the processes to get data out of a lot of these third-party systems. We use cloud tools such as Azure Functions, PyDream. We've moved to Dagster in the past year. We keep all that data in our data lake, and a lot of cloud products, scalable Postgres instances. We use crunchy data. They've been acquired by Snowflake now. We've worked with Cassandra a little bit for some of the wide columns and time series data. We're trying Databricks now. That's probably where we're going to go in the future. But basically, we take all that data, we host it in a data lake, we replicate it every night to basically 2 databases, one that'll handle the geospatial data, we use PostGIS for that, and just a local instance of Postgres for the tabular data. And then within Dash, we're kind of able to cache and refresh that data every few hours. Some of the data is live, some of the data is daily, some of the data is monthly, but the cache can make sure everything's really fast or responds quickly to the user. And then with Dash, we're able to kind of handle apps life cycle for production apps. It'll handle all our security, something we just don't have to worry about. Snapshot Engine is a tool that will actually let us turn the data into, again, those reports that people want to see in Parker 8.5 by 11 on 17 paper reports. But you can also go back and slice and dice data to analysis. So right now, we take snapshots of a lot of key reports every day. We'll email those out to clients. We'll connect and do notifications. And then the analytics platform is logged and people go and slice and dice data. So what we are showing here now for what we're going to do for Vibe Analytics is basically allowing the users to export that data directly through Dash so we can use it with our tools and let those customers vibe with their own data. These are just results of what we have seen with our customers on kind of having data analytics versus not. There's real money to be made on these projects, the cost savings on these projects.